Right, so I've just updated NASM to 3.02, so I'm just going to regenerate the listing file and check the difference here. So it looks like IRET basically just doesn't have a rexw prefix anymore. So if I go to forms and do IRET, looks like here I had to use enkwidth keyword to match what NASM was doing, so that's not necessary anymore. Go test should still pass doing that. Okay, so the first instruction that I want to move on to is actually going to be VBROADCAST, because I missed these ones with SSSD and things like that. These are actually going to be basically the same as the existing VBROADCAST instructions that I've got. If I just take these from down here with like 64x4 being the last one and the Q ones as being the first ones and just put them in here, I can change Q into SS, and I can remove the P. And these ones don't have a general purpose register version. I think this one also doesn't support XMM. And I can make a copy of this to do SD as well. And SD definitely doesn't support these XMM destination ones. So if I just regenerate the listing file with those, that looks okay. So we'll just go and take all of these. Oh, also I need to actually change broadcast I into broadcast F. Let's regenerate that. Okay, so I just need to take these mnemonics now over to the enum that I've got. Add them in, deduplicate. Let's just shuffle these around a bit to organize them a bit better. Okay, and then we'll just take these and add them to the name table. Then we'll take these and add them to the form table. So we'll make each of these into an empty form table. And actually, now that I think of it, these are basically just going to be the same as the existing I ones here. So I'll just take up to broadcast Q, and I'll actually just replace these. This will be, instead of VP broadcast Q, this will be VBROADCASTSS. We'll also copy, oh, and we don't have the general purpose register form here. SS won't have W, but SD will have W. So this one is SD, and then these broadcast I can change into broadcast F. SD didn't support XWord at all, so we'll just take that out. This one does support XWord, I think, and actually this one doesn't support XWord. These two don't either, so actually I've got too many widths on the VP ones as well, so I guess I'll just go and fix those. So this one I think does have XWord, but these ones don't, and this one is just YWord. This one is YWord and ZWord, and this one is just ZWord, I think. So let's just do a go test on this. Okay, so we've got a load of matches, but we don't have the correct like opcodes and things. So this is 663818. So let's go to SS here. So this is 663818. So I guess all of these are probably going to change to 18. Then we've got, well, let's just run that. Then we've got this one, F32x2 is actually 19. So this one is 19. Here we've got F64x4 is 5B, and oh, sorry, 1B and 1A for the other one. So it looks like these 5Bs are changing into 1B, And 5A here is changing into 1A. So broadcast SD, we've just got 18 becomes 19 for these ones. So this is 19. Okay, so that's broadcast done. Next, I want to move on to these conversions between PS, PD, and PH. So we'll start with PS to PH here. So let's just go to the encoder assembly tests, and we'll go to the top here. So this is VConvert PS2PH, and these ones are just MRI encoding. So we'll do XMM0, XMM1, and then an immediate. So this is M. This one can be memory access. So we got X, Y for VEC. So we'll just do this one and change this one to Y. Then we've got, let's see, this is just X, Y, and Z. But these ones support op masks with zeroing masks, and the ZMM one supports SAE. And actually, this SAE is on the modRM reg operand, where I think I always assume it's on RM. So this may be the only instruction I've ever seen that actually does this. So I may need to change the encoder a little bit to make this one pass, but we'll see. Okay, anyway, so we'll just take these, change these to have, we'll use like an upper register to force EVEX on all of these, but on this, on these register ones, we'll just choose an op mask to test support for here. Then this one is going to be Z, but I think with Z it's now going to YMM. And this one has SAE as well. So SAE is on the source. I wonder if this is, since it's on the source here, I assume I can just use it on both of them. Let's just try this. Okay, that looks like it's okay. Let's look at the listing. We don't have any duplicates in here, so that's fine. Okay. Well, let's move on to PHX. So this looks like it's, so this is actually RM, so I'll do this as a separate thing. So we've got VConvert PS2PHX. So this one is RM. So we've got RCX here. And since these are both source of XMM, I think I'm going to need to be a bit more explicit about memory size here. So I'll say O word for this one, and then the broadcast for this one is actually going to be D word because the element size is PS, which is 32-bit. So this is 1 to 4. Let's see, we've got broadcast. We also have op masks because these are EVEX only. So we'll just choose an op mask here. And then we go up to YMM, and this is going to be Y word, and that stays as D word, but because it's Y word, it's 1 to 8 now. Then we got Z, but Z is not going to XMM, this is going to Y. But these two can change to Z, and this one stays as D word, but now it's to 16. Okay, that looks correct. So that is PHX. Let's do PD to PH, which looks like it is the same, except instead of, does this one have SA? No, this one has rounding actually. So over here we'll do some rounding. We'll do RN SAE. Let's just make sure that's okay. Yep. Then we'll just copy this one and we'll put PD on the, oh, sorry, PD2PH on here. But because the element size is doubled, we need to halve the number of lanes that we broadcast to. And because the element size is doubled, the explicit annotation for the memory size should be the element size, which is keyword here. And then I think in this one, I'll just check, the ZMM one actually goes to XMM instead of YMM. So let's just go to XMM. Let's just test that. Okay, that looks like it's okay. So now let's do a convert PH to PS. So PH to PS is RM again. So do V convert PH to PS. So here we've got XMM 0, XMM 1. This one is memory access. Then for VEX we also support YMM, but actually this is YMM with XMM as the source. Then we've got EVEX, which has the same stuff but with op masks and zeroing masks. So we'll put the op masks on here, we'll do K2, Z. This one also goes from XMM as a source here, but this one now has SAE and it's a YMM source. So this one changes to Z, this one changes to Y, and this one also has SAE. No broadcasts on these ones, but there are broadcasts on these PSX ones. So let's just copy. PSX is only EVEX, where it goes XX, YX, and then ZY, which is the same as these. So this is PSX. Then we've got op masks and zeroing on all of them. We've got SAE, but we've also got broadcast here. So this one is, let's see, we'll copy this one. And broadcast here, I think, is going to be 1 to, wait, this is a converts. I've missed out the P here. This is PH. PH to PS. And PSX. So here we've got 1 to, let's see, how many is this? This is 4, 8, and then 16. So this one needs to be 1 to 8, and this one should be 1 to 16, I think. That looks all right. And then finally, we've got PH to PD here, which looks the same as the PSX one again. So we'll just take all these PSX ones and we'll change these to PH to PD. PD, I think this is, yeah, so we've got op masks, XX, YX, and then ZX. So this one should be X here. This one is SAE, which is also fine. And then we've got broadcasts. Oh, and I'm mismatching the number of elements here. I guess there should be 4. Is this one 2, 4, 8? We've got a mismatch in the number of broadcasting elements on line 56, which is this one. PH to PD. I would have thought that this would be 2 because it's packed FP16 values and store them in here. So, and we're converting to FP64, and you can only fit 2 64-bit values in an XMM here. So I would have thought this one should be 2, but for whatever reason, it's rejecting this one, so I think we'll just skip that one. We'll comment it out. For now, though, we'll just create these test lines. And we'll go and comment out that one that isn't doing the broadcast, which is this one. Let's just check this though, because the sizes are probably wrong. These ones should be, let's see, we've got YMM. This one is, oh, okay, yeah, these ones are VEX, so this one should actually be Y word. These two are X word, which is correct. These two need to be Y word, and then these two need to be Z word. Then we've got, for this PHX one, we've got X word for all of these. Then for these ones, we've got Y word, and then for these ones down here, we should have Z word. Then the PD ones were the same as the PHX ones, so I think this one should also be XXX, then YYY, then ZZZ. Then down here, I think these ones are all okay because we've got register names as the first thing, so my shortcut for doing this would have picked up on all of the first register names to do the correct sizes. So let's just regenerate the listing. Then we'll just go and take all of these mnemonics and add them into the tables. So let's just go and take these ones. We'll go to mnemonic. Actually, we'll just put them above this one here. So we'll put them in here. Let's just go and get the duplicates out. Remove that one. So this is PH, and then we've got PH. So this is something to PH and then something to PS or PD here. I think that is okay as like a grouping. So let's go and add these to the name tables. Okay. Let's just do that, and then we'll take these over to the form table, put them in here, and we'll just change these to be empty form tables. Okay, so go test should fail as usual here. So we're going to do PS to PH as the first instruction. So this one we've got VEX, where these two are the same encoding and they're just differing by the width. So we'll just say this is family VEX. The width is going to be X word or Y word. Op N here is MRI. Op1 can be VEC or memory. Op2 can be VEC, and then Op3 can be immediate 8. Then we got a prefix of 66, map of 38, I think, or 3A. Then we got an opcode of 1D. Then we also need EVEX. So EVEX here is the same encoding again, but this time we also allow Z word. So we've got Z word here. Let's just do the test and see what we fail on. So yeah, we're failing on EVEX here because we need to accept op mask and zeroing. Then this one we need to accept SAE on op2. Okay, so I think this is... Yeah, this is the one where SAE is actually on the reg field, which I think this is the only instruction I've ever seen where this is actually happening. So if we go to the encoder and we look for like rm.is SAE, I always assume that this is on RM, but it seems like in this particular instructions case, SAE is actually on reg. So maybe what I'll do here is I'll just say EVEX-B is rm.info or reg, like bitwise ORed with reg.info. And then instead of RM here, I'll just check on that sort of combination of them. Okay, that worked out all right. So next one is PHX here, which is also 1D, but this one is a little bit different in that the map actually says map 5 here. So the maps we've got right now is that the 0 map is just nothing. This is 0. This is like the primary opcode map. Map 1 is the secondary opcode map, which is 0F. Then the second one is 0F38. The third one is 0F3A. And then we have map 5. I think there's also map 4, 5, 6, and 7. These ones are literally just counting up. So when they're encoded in the EVEX prefix, you basically have 3 bits to represent the map. So, you know, if your 3 bits are encoding 1, you get this map. If you encode 2, you get this map. If you encode 3, you get this map. Map 5 is literally just saying to set those 5 bits to, you know, 101 for map 5, because this is 5. So for these instructions, I think I need to actually just add new maps here. So this is already, you know, 0, 1, 2, 3. So this is 4, 5, 6, 7. So now I can use these map constants, these enums, to set the forms for these things. So let's go and have a look at PHX again. So PHX is EVEX only. So we'll just do family is EVEX. The width for this is, we've got all 3 widths. So we've got X word, Y word, and Z word. The op n for this is RM. Op1 can be a VEC. Op2 can be VEC or memory. So now the prefix for this is 66. Map is map 5, and opcode is 1D. But this still won't match because I need to allow broadcasts and stuff. So this one has to allow op mask and zeroing. And then we need to allow, so here we've got memory. This should be allowing memory though. So this is still PS to PHX. Could not match instruction form. Okay, let's just go and have a look at the tests and make sure that these are actually correct. So we've got PHX. Oh, these ones have O word in them. Okay, let's just get rid of these from the tests. I think that's all of them. We'll regenerate the listing and do the test again. Okay, so now it can't match the broadcast one, which is fine. So we'll just add broadcast onto here. Now it can't match for rounding. So yeah, this one is needs to allow ER on the Z word version only. So let's actually split this up. So this one is Z word. And then on the op2 here, we also need to allow ER. Okay, so we're on to PD to PH now. So PD to PH is basically the same thing, but this time we've got 5A with W set. So this is PD to PH, and this is 5A with W set to 1. So then we've got PH to PS. So PH to PS is, yeah, we've just got 2 for VEX here. I'll just take these ones. So for this one though, we don't allow any kind of, we only allow SAE on, do these ones have SAE? PS to PH did have SAE. Okay, I think I should be splitting this one out as well actually then. So this one's not Z-word. These ones, this one is Z-word. So the non-Z-word one needs to get rid of SAE here. So that's SAE. For ER, that's all okay. Okay, let's just copy these ones up again. So for these ones, it's 1D still, but this time we've got 3. Oh, we've still got 3A as the map there. This one is, oh, this one is, okay, let's go to PH2PS. So this is 1-3 for all of them, with 3-8 as the map. 6-6 is still fine. Then we've got 2 VEX ones. This is also operand encoding RM instead of MRI. So instead of these ones, this should be R, which is VEC. This one should be MEM, and we don't have an OP3 at all. So the EVEX ones do support op mask and zeroing, so that's fine. And then this one down here, the ZMM for both EVEX ones do support SAE, so that one is okay as well. And this one should be MEM. So do MEM on these two. Okay, let's just see how that is. So this is PH2PSX now. PH2PSX, let's just go look at that. Oh, that's these ones, okay. Oh, this one is map 6, okay. Okay, let's just copy these EVEX ones down into here then. This is now map 6. And it's still 1-3, and we've still got SAE on Z-word only. PH2PSX, we need broadcast on this as well. So we do broadcast here, and broadcast on this one. Okay, so PH2PD is going to be basically the same as the PHX one. So let's just take those. We've got SAE, we've got broadcast on them. So this one is 5A with map 5. So instead of map 6, there should be map 5, and then this one is 5A. And we've got something else wrong here. No prefix, so we'll take off prefix 66 as well. Okay, so that was a VBROADCAST and a PSPD-PH conversion.